In this lecture, we're going to learn about forward declarations. And this is a feature we have in C++ to introduce a name in a file, and that's going to be mostly name for classes. And we're going to introduce a name where we need to use that name, but a definition for that name is not needed. So to really explain this, suppose we have a dog class. You can see that here it is a simple class. We have a simple public section, we have a private section, and this side we really are doing nothing complicated. We're just going to print the name for the dog. But we have another class which is going to use this dog class. And that class happens to be the form class here. And we have a simple declaration for a member function. The member function is useDog. It's going to take a dog object by reference, but this is just a declaration, so we don't really need a definition for the dog class. If you're trying to compile this without including the dog class, that's not going to work because the compiler is not going to know what dog is. You can solve this problem by including the dog header. This is going to bring in the dog class, and this is going to work. But please remember that we don't really need a full definition for the class. And using this setup here is going to cause for the header for the form class to be recompiled every time we change something in the dog header. And suppose we are including this form class in maybe 1,000 classes, so that's going to waste a lot of time in compilation time. So we don't want this. C++ provides a feature we can use to solve this problem and not have to include the dog class if we don't need the definition here. And what we can do is do a forward declaration for the dog class. The syntax to do that is really simple. It is what you see here. You say class, you say the class name, and you put a semicolon. This is going to forward declare this name in the eyes of the compiler. And in other words, we are telling the compiler not to freak out when it sees this name. We are telling it to wait later. When the definition is needed, it's going to see the definition for that class, and our code is going to compile. And the good benefit of this setup is that every time we change something in the dog header, our from class doesn't need to be recompiled because we don't really need the definition. The definition is going to be needed when we use something that requires a definition for the dog class. But please note that this forward declaration thing is not going to always work in your class headers. For example, if you happen to need the definition for the dog class, either by calling a member function on a dog object or having a member variable of a dog type, this is going to need a definition. Forward declaration is not going to work here. You will need to include the dog class because you need the definition to be able to call the member functions. You need the definition to be able to build dog objects. So this is going to require you to have the dog class included in front of the form class here, and you need to be aware of this. But if you don't need a definition, you can use forward declaration, and that's going to be really cool, and that's going to save you time when compiling your code. That's the message here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is forward declarations. We're going to grab our template files pretty quick. We're going to put them in place. And we are going to move this little guy and drag and drop in Visual Studio Code. To open this up, we're going to have our main CPP file. We can clean it up a little bit. And we're going to set up our two classes. We're going to set up our dog class. We're going to say dog.h. We're going to put in a header, and we're going to put in a CPP file. We're going to say dog.cpp. I am going to put in the code for my dog class. It is really nothing complicated. Remember to put in your include guards. And this is just the class. We have a member variable of type std_string, and we're going to have a member variable to print information about our dog. And we have a few constructors here. Nothing complicated. We are going to head over in the dog CPP file and put in our implementation, mainly for the constructors here. So this is done. Now we want to add the form class, which is going to be using the dog class here. So let's do form.h for our header, and we're going to do form.cpp for our implementation file. I am going to head over to the form header file, and I am going to put in my code. It is nothing complicated, but we have this thing here. Let's remove it. And we're going to include our dog here because we have a function that is going to use our dog. But remember that this is not going to require a definition for the dog class because we're really not using this in this header file. So this is something we can do. But before we really explore what we want to see here, we're going to do the form CPP file. I am going to head over there and put in my code. We're going to have the implementations for the constructors, but we have a problem here. We are saying use dong. Is this what we said in the header file? No, it is not. So we're going to fix this a little bit. Thank you, Visual Studio Code, for finding this problem for us. So the setup we have here in the header for the form class, we have a function which is going to use our dog object, and it is taking the dog object by const reference here. But in the header, we don't really need the definition for the dog object. But for this to work, we need to include the dog object. If we don't include it, we're going to get a problem because the compiler won't know what this dog name here is. So we need to introduce this name, and we do that by including like we are doing here. But this is going to waste a lot of compilation time. Try to think about the case when we have this form.h header included in other headers. And if the dog implementation changes, for example, people come here and they change things about the dog class here, the form headers are going to be including the dog, so they will need to be recompiled. And if this header is included, for example, in 100 other headers, all those headers are going to be compiled. So this turned out to be a problem, and C++ found a way to try and solve this problem. And we can solve this problem by forward declaring our dog class here. We do this by just saying class dog and putting a semicolon, and this is going to be a forward declaration. This is basically going to tell the compiler, if you see this name, don't freak out. You're going to see a definition for this later when you actually need to use the dog. But at this time you don't, so don't give me a problem. That's what you are telling the compiler. And if we try to compile this program, it is going to work. We can go in main and, for example, let's include dog first because that's the dependency. I'm going to do that. And if we go down and create a dog object, we can create a dog, call it dog1, and give it a name, maybe Fluffy. You can do that. I think we have a constructor that does this. We can take a name here, so that's really cool. We can go down and create a form object and say form1. And we can say form1, we can put a semicolon here. We can say form1, use dog, and use our dog1 object here. I think we can do that. So if we run this program, we're going to be printing information about Fluffy here. And if we build it, we're going to see that it is going to work. So let's do this. We're going to see that the build is good. We can bring up a terminal to be able to run this. We can clear and run Rooster. We're going to see that we have the name for the dog, but we are using forward declaration here, and this is going to save time if, for example, this from header happens to be included in other files, because if we change dog, then the form won't need to be recompiled, and this is really cool. But please note that forward declaration won't always work. For example, if we happen to have a member variable for dog, let's do that. We're going to say dog and say dog member. And try to compile this program, we're going to see that now we have a problem. And Visual Studio Code is going to give us a hint, and we are trying to use an incomplete type here because a forward declaration is really not giving us all the information we need to use a dog object. So forward declaration won't work here if you need a member variable for the dog object. But this won't also work if, for example, we need to call member functions on our dog parameter. Let's set up another function here. We're going to say void do something. We can do that. And we're going to take a const dog object by reference. We can do this. So let's say dog param. We can say that here. And we have the definition of this guy in the header file. So we're going to say dog param. And for example, printful. We can say that. You see, we can't even have autocomplete because we don't have all the information to call member functions on this guy, but we're going to autocomplete this ourselves. So let's do print info. I think this is the name for the function here. Let's go back to dog header and confirm that that's print info. We can copy this and put that in our form header. I'm going to say print info and make sure that we don't have any typo. You see that this is not working. If we want this to work, we have no choice but to not do forward declaration and do good old include. So we're going to come back here and say include dog.h. And now these things are going to work because we have full definitions for the dog class here, and this is going to work. But if you don't need definitions for this dog class, for example, we don't have this function here, we don't have this member variable, we can use forward declaration, and that's going to work. So this is really all I wanted you to see in this lecture, seeing that forward declarations can really come in handy if you have class definitions that don't need definitions for other types, but you are using those types as parameters in your class. That's going to really come in handy, and it's going to improve on your compilation times. I am going to stop here in this lecture, and I hope you found it useful. And in the next one, we're going to try and recap on what we saw in this chapter. Go ahead and finish up here and meet me there.